Okay, so now we're going to talk about molecular formulas, and we're going to go through an example that asks you to calculate a molecular formula from given data. So this problem asks, the compound with a molar mass of 171.0 grams per mole contains 14% carbon, 41.5% chlorine, and 44% fluorine, and this is what's called a CFC, or a chlorofluorocarbon. These are actually banned now in the United States because of their role in ozone depletion, but what this problem wants us to do is find the molecular formula of this chlorofluorocarbon. So if something like this were discovered, scientists would have this data, and then they would have to figure out what the molecular formula is based on just this information. So if you notice in this problem, it tells us we have 14% carbon, 41.5% chlorine, and 44% fluorine. Now, before you find a molecular formula, which is the actual formula, you need to know what's the simplest ratio between these elements. So what that means is we need to first find the empirical formula. Okay, so before we find this molecular formula, we need to find the empirical. Now, in this problem, we're given percents. Remember, I told you when we're talking about empirical formulas, it's really important to assume we have 100 grams of a compound. Okay, because if we have 100 grams of a compound, we can just convert these percents directly into grams, and it's going to make our life so much easier. So first, what we need to do is assume 100 grams. Take each of these. That means we have 14 grams of carbon, 41.5 grams of chlorine, and 44.4% fluorine. Right? Once we have our grams, we're finding the empirical formula now, right? So first thing we need to do is convert to moles. So here are my masses. I use the molar mass to get to moles. So I have 1.1657 moles of carbon. Okay, notice I went out to about 5 significant figures. The more significant figures you use in problems like these, the smaller your chance for error. So 1.1657 moles of carbon, 1.1707 moles of chlorine, and 2.3368 moles of fluorine. Okay, so we have our moles now. Now, once we have our moles, we need to figure out what's the ratio of these moles. So to find the ratio, you divide by the smallest number. Okay, so this top number, my moles of carbon, that's my smallest number. So what I'm going to do is I'm going to divide each of these mole values by that smallest. Okay, and that's what I did right here. So I divided each one by 1.1657. And what I found was I get 1 for my ratio. You always should have one of your values that equals 1 because you're dividing by itself. So that's just kind of a check to make sure you're doing it correctly. So I get 1.00 for carbon, 1.00 for my ratio of carbon to chlorine, and I get 2.00 for my ratio of carbon to fluorine. So what that means is these values are my subscripts. Okay, so what that means is my empirical formula is CClF2. Now the problem doesn't ask for empirical, it asks for molecular, but finding the empirical is the first step. So once I have the empirical formula, it's going to be really helpful to find that mass. So what we need to do is we need to use the periodic table to find our mass of our empirical formula. And so what I did right here is I used carbon, chlorine, and 2 times fluorine, because that's my empirical formula. I found 85.46 grams per mole. Now what I have to do is I have to figure out how much bigger is my molecular formula than my empirical. Now, just a way to make sure you're doing everything correctly is your molecular formula mass should either be greater than or equal to your empirical formula. Your molecular formula should never be less because you can't have fractions or decimals as your subscripts. And so what I have to do is I have to determine the multiple, right? How much bigger is my molecular than my empirical? And to determine this multiple, what we actually can do is just divide our molecular by our empirical, right? Divide the bigger by the smaller. Now what I find, remember this molecular formula was, or this molecular mass was given in the problem itself. I divide 171 by 85.46, and I get 2.00. What that means is my molecular formula is 2 times bigger than my empirical. That means I need twice as many atoms in my molecular as my empirical. So what I can do down here is say, well, here's my empirical formula. Let's just multiply all of those subscripts by 2. So what I get then is I get 2 carbons, 2 chlorines, 4 fluorines. That is my molecular formula. Okay, that's my molecular formula because this is my actual number of atoms that are in my compound. Notice when you divide all these by 2, you get the simplest whole number ratio. That's your empirical. So molecular is what we actually use. That is what our actual compound is versus the empirical, which is the simplest ratio.